Hi, my name is Daniel Blackburn, and today we're going to talk about the plant's secondary macronutrients, calcium, magnesium, and sulfur, how they behave in the soil, and how to supply them, what is the strategy for providing adequate plant nutrition on these elements. All right, so again, this is about calcium, magnesium, and sulfur nutrition to plants. Yeah, so calcium and magnesium, they will behave very similarly in soil because chemically they are very near each other in the group 2 of the periodic table, second column. But sulfur will be radically different, and we're gonna talk about what these differences are. Um, anyway, the calcium and magnesium, they will be present in the soil as cations, yeah, as cations, whereas the sulfur, it's will be more present as a sulfate in anions. Although the sulfur can be in a huge number of chemical species in the soil because its ability to be changing its oxidation states. Uh, Nevertheless, the most common one that we will find that will be available for plants is sulfate, SO4. Yeah. Why we consider these elements secondary macronutrients and not primary like phosphorus, nitrogen, and potassium? The difference is that the plants need these nutrients in lower concentration than they need phosphorus, nitrogen, and potassium. So normally in the most situations, you can go without using them as fertilizer. But if in special situations you might need to use them, especially for sulfur now, because we don't have atmospheric pollution anymore and acid rains depositing sulfur in our soils. So why is calcium is important for plants? Calcium is important for wall structure, for the tissue development, meristems, root development, enzyme activation, nutrient transport, molecular signaling, membrane stability, disease resistance. It's very stable and is not really well transported in plant tissue. And it's actually calcium is the counter ion that will form the precipitated forms of all the organic acids in intracellular environments. And for example, if the plant produces phytic acid, the storage of this phytic acid will usually be calcium phytate, yeah? Not phytic acid, but calcium phytate. So calcium is, whereas potassium is always the go-to ion for soluble, to be the counter ion in soluble forms. When you have to store this nutrient in precipitated forms, these are usually being counteracted by calcium, and calcium is important for regulating these, counteracting the negative charge of the organic acids inside the cells. So calcium is usually considered an element of smaller importance. The smaller importance is usually due that we have a huge amount of calcium in terrestrial environments. So because of that, it's very hard to find situations where calcium is so deficient that you will need the calcium fertilizer application in order to have an adequate calcium nutrition. But nevertheless, we can find these situations even in high calcium soils. So I'm going to explain this in a little bit. So one of the main things about calcium when you identify that you have a calcium deficiency is you have the leaves of the plants are curling. You know, they're curling and bending in themselves like they are trying to make like a round shape and, you know, packing up together like you see here in the photograph, you know. So this is very typical, and you will see that in tomatoes, potatoes, beans, There's dicotyledons mainly. You will see this behavior where the plants are curling on itself, and this is the symptom of calcium deficiency. Yeah, trying to grow, but there is not enough calcium for promote this tissue growth. So this sometimes you can confound these symptoms with other problems of the plants, for example salinity. But usually when you see the curling of the leaves, that is when you will have calcium deficiency. So the calcium cycle will be more similar to what is the phosphorus cycle and the potassium cycle. You usually don't have any atmospheric component of the cycle. It's usually coming from the rocks and in the water, and it's being cycled into the plants and into the soils, and being decomposed in cycle from through the organic matter, yeah, and until it's lost and reach the waters. There is one big thing that we have to mention about calcium, is that the calcium cycle is very tightly linked to the carbon cycle. The reason being is because the CO2 dissolved in water forms carbonic acid, and the carbonic acid reacts with calcium and it forms calcium carbonates. All this white material that you will see on in sediments and soils, and it tends to be carbonates that are precipitated on the soil. So the calcium carbonate is a very big forms of calcium storage on the soil. They're usually very unavailable to plants, and this is one of the reasons why you can find in Oman calcium deficiency in some situations, because even though you have sometimes 30% of calcium carbonate in the soil, the calcium carbonate will represent a form of calcium that is insoluble in many times. You need to acidify the soil in order to release the calcium by emitting CO2 from the soil. And sometimes the alkalinity of the soils is so high, especially when you have sodicity problems, and this alkalinity, when it's too high, the plants are not able to counteract this alkalinity by using only root exudates. And if they're not able to acidify the rhizosphere to release the calcium, then you might have a calcium deficiency, even if you have a soil with about 30% calcium carbonate. So you might have a huge amount of calcium in the soil, and even then you might have calcium deficiency depending on the situation. But in general, overall, around the globe, calcium represents 3% of the Earth's crust. So in general, you will have enough calcium for nutrition. In very specific cases is where you will need to apply calcium for plant nutrition. And when you do need it, the form that you apply is by using lime. So whenever you have very acid pHs and you already leach the calcium from the soil because of the acid pHs, when you use the lime to correct the pH, you are already applying calcium. So in that way, you don't have to worry about calcium nutrition when you are correcting the pHs of the soil. In very alkaline pHs, then you will usually have a huge amount of calcium and other bases also, but the main problem will be when this calcium is very insoluble. Yeah. The case for magnesium in the plants, although magnesium has a similar behavior in soil, it forms alkaline precipitates. It behaves very similar to soil, is very abundant in soil systems. The role that magnesium has inside the plants is very different from the one that of calcium. Magnesium is part of the chlorophyll structure, and the magnesium on the center of this chlorophyll structure head is what is able to absorb the wavelengths of light and vibrate these molecules, and this is what allows the photosynthesis to occur. So magnesium deficiency is directly affecting photosynthesis. Yeah, whereas calcium deficiency is usually affecting tissue growth. Yeah? But magnesium, its unique role is on the chlorophyll and the photosynthesis. So the magnesium deficiency, it tends to look a little bit like what you see for potassium. You have this intervenous chlorosis, because similarly to potassium, the magnesium can be transported. Yeah? You can transport magnesium from old leaves to new leaves. So whenever you have deficiency, the plants will try to deplete this magnesium and bring it to new tissues, and that's why you see this intervenous chlorosis happening, yeah, with magnesium. Very different from the symptoms for calcium also. So chemistry in soil is very similar to magnesium and calcium, but the behavior in plant tissues and the symptoms in plant tissue, they are radically different. So the magnesium cycle, as I was saying, is similar from calcium. Yeah, it will not have an atmospheric component. It's been cycled through the rocks, into the soil, and in the soil it's been uptaken and deposited on the soils and cycle, and then it's leached or lost to waters. As the main sources that you will have for a nutrition of calcium and magnesium, there will be limes, yeah? So calcitic lime, dolomitic lime, they are the main sources of supply of these nutrients to plants. You can have combined with even sulfur, like gypsum, calcium sulfate is the main form of that you apply sulfur to the soils, and you have many other combinations: magnesium sulfate, magnesium oxides, sulfate of potash magnesium. There is actually a variety of different fertilizers that contains calcium, magnesium, and sulfur, but the main ones will be calcitic and dolomitic limes. So actually, you tend to expect more calcium and magnesium deficiency when you have low pHs, and by correcting the pH right away, you will have that you're already using enough calcium and magnesium as fertilizers. Yeah. Sulfur, on the other hand, is a completely different story. Yeah, sulfur, its role in plants is mainly because it's part of amino acids and proteins. So the behavior in the plant is similar to the nitrogen, in the way that the nitrogen, the bulk of the nitrogen in the plants are in the protein molecules. Similar that will be for sulfur, just the only difference is that for the sulfur, you will have a lower amount than you will have for nitrogen. So you need less amount of sulfur than you have for nitrogen, but you will have a similar behavior in the plant and also in the soil, in a sense. I will explain a little bit more about the behavior in the soil, but sulfur is hugely important in different processes that are regulated by these proteins. So every protein that contains either cysteine or methionine will have sulfur, and the sulfur in the proteins, it's very important for the stabilization of the structure of these proteins, because the sulfur can form disulfide bonds, and therefore the structure of these proteins becomes a little bit more rigid, and allows the proteins to have more stability and do not lose the activities of different enzymes in different conditions. So the strategic location of these disulfide bonds on the protein allows for having the formation of three-dimensional structures on these proteins, which are hugely important for their function. Okay. So sulfur is part also of vitamins, and is very important for chloroplast and plant growth function. Yeah, nitrogen fixation by legumes also is highly influenced by sulfur nutrition, and sulfur is not very mobile in plant tissues. No, not very mobile in plant tissues. The symptoms of sulfur deficiency will be yellowing, yeah, like nitrogen, because it's like the reason is because you cannot produce enough proteins, and then therefore you have this yellowing of the leaves. Yeah? So this is why sulfur is similar even to how it looks like on the plants, the deficiency of nitrogen. The fruit maturation also, it's very dependent on sulfur. Different from nitrogen, you can have sulfur toxicity symptoms. Yeah, you can have sulfur toxicity, but nitrogen also you might have ammonium toxicity. So it's kind of in the same ballpark of physiological roles. Yeah, nitrogen will have more physiological roles than sulfur because it's involved also in DNA and RNA. But similarly, you will have sulfur toxicity if you have excess sulfur applied. Usually that is when you use excess of leaf fungicides containing sulfur. Otherwise, it will not cause toxicity. Usually you would not find toxicity. So the sulfur cycle is very complex. I will not detail completely. And one of the main things that you will find on the sulfur cycle is that it's heavily dependent on microbial transformation of this. I have a lecture on soil microbiology course which details all the microbial processes on the sulfur cycle. And if you want to know more about all the transformations on the sulfur cycle, please go for that lecture in the playlist of environmental soil microbiology, and then you will see all the different bacteria they are influencing these sulfur transformations in anoxic and oxic environments. But mainly you will have that sulfur will have a heavy atmospheric component, either by atmospheric pollution through the burning of fossil fuels, or by volcanic activity, or by bacteria that are reducing sulfur and emitting hydrogen sulfide. So this atmospheric sulfur can be deposited in soils by acid rain, and can be uptaken and cycled in the soils, in the plant tissues, and decompose. Similar to the nitrogen, you will have the most of the sulfur in the soil will be present in the organic matter. So if you have low organic matter, you will likely have low nitrogen and low sulfur. So in waters of soil, this sulfur will have their own cycling through different organisms, and will go through different processes of reduction and oxidation, either as a source of the nutrient sulfur, but also as a source of energy for different chemolithotrophic microbes. These chemolithotrophic microbes are also present in soils, and they're very important also for the dark carbon fixation, because these are autotrophic microbes. So I will not go very deep on what is the microbiology of the sulfur cycle, but please, if you are interested, go in the other lecture in the environmental soil microbiology, and that will be explained in detail. What we are really interested in now for the sulfur for this lecture is about what is the implications of its chemistry for plant nutrition, and what should we do about it. Okay, so actually the main source, the main pool of the sulfur in the soil is organic sulfur. The main pool of sulfur in the soil is organic sulfur, and this is being immobilized by microbes and plants in organic molecules, and mineralized by the microbes into sulfate. Some of the sulfate, if you have reducing condition, can be transformed into elemental sulfur, or be emitted as a gaseous form to the atmosphere as hydrogen sulfide. The sulfate molecules can be also leached, and the sulfur can be taken off by from these fields through plant tissues, and also by erosion. Yeah. So if your concerned about the level of organic matter that you have on your soils, and if you want to replenish the organic matter in your soils, most likely you have enough sulfur for plant nutrition, because they will be coming from the hydrolysis of the proteins on the plant residue and the organic matter that you're adding. There will come enough sulfur for plants for sure. But there are other ways that you can supply this for plants, and one of the ways is through elemental sulfur or gypsum calcium sulfate. In acid soils, sulfur can be a problem. Yeah, sulfur can be a problem in acid soils. So what happens is, if you have excess sulfur, this sulfur tends to take the form of sulfuric acid. Yeah, it's the sulfate, when it's compensated by hydrogen, is sulfuric acid. So in these situations, in acid soils, they're usually in tropical regions, weathered soils with high rainfall. If you have that this is excess sulfur is happening on the soil, the sulfuric acid will dissolve the iron on the soils, which the soils contain a huge amount of iron. There are oxysols in general, and excess sulfur will dissolve the irons, and these irons will be a huge contaminant of waters. So you will see these water courses that can be heavily contaminated by this dissolved iron. This is due to the excess of sulfur that can come from mining or volcanic activity, or any other source of contamination of sulfur can be a big problem for acid soils, where we can further acidify and dissolve the iron on this situation. But this is not the case of Oman. Oman is usually the case of having very alkaline soils, and you will have minerals, namely gypsum, in the soils that will be accumulated inorganic sulfur. So you might have in alkaline soils, like the ones in Oman, you will have the possibility that you will have not only sulfur in the organic matter, but a lot of sulfur locked in inorganic forms like calcium sulfate. In these calcium sulfates, you can have huge deposits like here it's showing in Palestine, but in Oman, it will be part of the soil minerals. Yeah? Like you have carbonates, you will have some gypsum also in these systems. This is very typical when you have also seawater intrusion. You will have that the soils will contain more sulfur than the other soils, because the seawater will have some amount of sulfur that will be added to the soils also. Where did this sulfur come from when you add them for fertilizer? This sulfur is usually mined in the past, were mined for volcanic deposits, volcanic craters. This is elemental sulfur being mined here. But lately, this is coming from the oil industry. Yeah, the production of gas. There is a process, a microbial process, that is used for removing hydrogen sulfide from the gas, and then what you end up is a lot of elemental sulfur, and this is being used now as an amendment for soils for different reasons, mainly for supplying sulfur to plant nutrition, but also for acidifying soils when the conditions are highly alkaline. All right, so you have that sulfur is mainly locked in organic matter. When you want to correct sulfur, usually gypsum is the form of sulfur that you apply to soils. Calcium sulfate, that's both a source of calcium and sulfur. Gypsum will not change heavily the pH as lime would, but it will be a source of nutrients. It will be a good source of calcium also to neutralize the negative effect of sodium if you have high salinity. Normally you will have that soils which are very sandy, and when they're irrigated by flooding, like the case of date palms in Oman, for example, you might have sulfur deficiency. If you have excessive washing of the soil and the soils are very sandy, you might end up with sulfur deficiency in these situations. Normally, this is well counteracted in Oman by using a lot of manures. So traditional date palms in Oman, although they are doing this flooding irrigation constantly, and they have sometimes a high leaching of the soils, but they are usually using a lot of manures on the soil, so that these manures are a good supply of sulfur. So this is why you don't see sulfur deficiency very often. The elemental sulfur is can be used for the acidification of soil, as I mentioned before, and this acidification has also some desirable properties when you're trying to leach the bases from the soil. In the case of high salinity, if you enhance the amount of protons, you will dissolve the calcium carbonates on the soil, and the calcium will help to leach this sodium. And also the protons will be able to displace sodium ions on the interchange complex on the soil matrix. So this is what I have to bring for you. So sulfur is hugely important in Oman at the moment, because Oman is it's oil-based economy, and sulfur could be a good complement for this gas production and exportation of this agricultural amendment for soils. All right, this is all that I had to bring for you today in calcium, magnesium, and sulfur. I hope you enjoyed. See you in the next lecture.